Does this look familiar? Maybe this was okay in the past, and that is precisely where it belongs. Now, with today's cutting-edge technology, the job has just been made quicker, easier, and cost-effective. In all sectors of industry and production where airborne dust and fly ash are an issue, the use of innovative machinery and automation to control dust has multiple benefits for the user. Save time and labour, redirect manpower to core activities, greatly reduced water consumption, save money and reduce environmental impact, improve air quality for workers, EPA and environmental compliance, prevent the risk of dust explosion or fire, increase efficiency within industries affected by dust. Borrowing from the principles of nature, Cold Mist Cooling Australia has researched some of the most innovative and effective technologies currently available for the control of fugitive dust. Our company is proud to offer a core selection of systems to suit virtually any sized project across a diverse range of applications, including waste transfer stations, landfill and recycling plants, mining and quarrying, construction and demolition, and cement and coal generation. On the back of outstanding results, Cold Mist Dust Control solutions are set to provide new standards in the context of environmental protection. Simply explained, there are two main aspects of dust control. These are to arrest dust before it becomes airborne. This is not where Cold Mist operates. Utilise Cold Mist's leading-edge dust control technology to deliver direct results wherever dust becomes airborne. Typical applications include dust generated during rock crushing at quarry sites, stockpile dust suppression, dust generated by materials travelling along conveyor belts, product transfer points, dust generated during construction and demolition work, cement and coal dust control, asbestos dust suppression. In all these applications, dust control is achieved by introducing atomised micro water droplets into affected areas, encapsulating airborne dust particles and driving them to the ground. Being small enough to have considerable hang time in the air, these micro droplets become the arresters of fugitive dust. Paramount to the operation is that the atomised water droplets are correctly sized. Too large, they have reduced hang time, fall to the ground prematurely and cause extensive wetting. Too small, and they flash evaporate or drift away before executing their function. Traditionally, atomisation has been achieved by forcing pressurised water through nozzles, and in certain instances, this remains a perfectly viable solution. The age-old downside of a nozzle-based system is clogging of nozzles and maintenance of the high-pressure pumps that are required to drive the nozzles. Larger orifice nozzles are preferable to small ones as they reduce the incidence of clogging and permit easier passage through both pump and nozzles of any solid particulates in the water. Other benefits offered by larger nozzle orifices are reduced filtration and reduced pump power requirements. In certain instances, rotary atomizer technology is a very attractive alternative. Researched thoroughly, the rotary atomizer has been around for a long time. Originally developed for use as a more reliable system for dispersing diluted chemicals in agriculture, these systems were mounted onto the wings of crop sprayer aircraft in preference to nozzles. Rotary atomizers require water delivered to them at a normal supply pressure, thus bypassing the need of a pressure pump. These systems are powered by either electric, hydraulic or pneumatic motors. Atomization is achieved by a mechanical fracturing action of the delivered water. Selection of both shaft speed as well as second stage atomizing basket will dictate degree of droplet size and volume of water throughput. Supplied in single or dual stage configuration, the droplets are emitted laterally in a radial spray pattern. When the RA is mounted overhead, similar to an overhead light bulb, the resultant umbrella-like spray will effectively blanket the targeted area. By adding a set of propeller blades to the motor shaft, called air assist, the spray pattern becomes conical, which resists wind to spray longer distances, thus directing the spray at the intended area of coverage. It also gives a higher ratio of air and spray mixture for improved coverage. Science dictates that environments affected by extreme amounts of dust demand a large volume of micro water droplets be introduced into the affected area to achieve optimal dust suppression results. The rotary atomizer is only confined by the volume of water that can be put through the system, a maximum of 16 LPM of atomized water. The rotary atomizer has been specifically designed to deliver outstanding results in smaller, more confined areas. Large area dust control. In the case of large areas such as demolition sites, quarries and stockpile operations, volumes of dust are generally greater and, as such, an increased volume of water droplets is required. This is where Cold Mist recommends switching over to the nozzle and high pressure pump option. Where increased area coverage is required, the extensive propulsion of mist is achieved utilising Cold Mist's barrel fans. Originating from the snowmaking machine industry, all these systems have been submitted to rigorous testing in the most extreme environments to guarantee their excellence today. Simplified, they are monster fans with nozzle rings mounted in front. A high-pressure booster pump pressurizes the water to around 15 bar, which is then fed through the nozzles. The resultant spray plume is propelled forward by the barrel fan. Fan motor sizes vary between 5 kilowatts and 28 kilowatts, with pump motor sizes up to 7.5 kilowatts. Water throughput can be up to 90 litres per minute. The Cold Mist range of delivery systems is loaded with features including manual or servo assist oscillation, manual or servo assist tilt, adjustable water output, remote control operation, choice of skid mount or trolley mount,